Hello, hi, I'm Jamie, and welcome to AXA XL Arctic Live. Great to have you all with us. Really, really lovely. And we are broadcasting from the UK Arctic Research Station up here in the Arctic. We are in the Ny-Ålesund International Science Village, and that is on the archipelago of Svalbard, sort of halfway between the top of Norway and the North Pole. So we are at 79 degrees north, North Pole at 90 degrees north. So we're fairly high up. In fact, I think we are the most northerly research station, certainly in this part of the Arctic, by meters. So I mean, we're at the north end of the community here. This session is an Arctic Q&A, so myself and Ellie, who's currently behind the camera, will be answering as many of your questions as possible about life and science in the Arctic. And we have schools from the UK, USA, Portugal, Ireland, Colombia, and Bermuda joining us. So big hello, Arctic hello to all of you. Really fantastic to have you with us. And a big shout out goes to Tuckerton Elementary School. Wonderful to have you with us on this Arctic Q&A. So what we're going to do is we're going to have a quick look outside and show you around where we are, and then we'll come back in and look at the questions coming through and try and get through as many of those questions as possible. So I'm just going to grab my microphone, come outside. It's actually turned into a beautiful afternoon. We had a bit of wind this morning, which wasn't great, so the science team had remained on station, but now thankfully that has now seemed to calm down, and it's a beautiful sunny afternoon out here in the Arctic. So looking down this way, we can see a few features here. We can see the sea here. This is fjords. That's a sea inlet coming from the part of the Arctic Ocean, coming through all the way down to the end of the fjord, where you'll be able to see the glaciers at the end here. And that's about sort of 10-15 kilometers away. The air is so clear here. It looks surprisingly close. And you can see a couple of things. You can see the sort of very sort of mottled, rough shape of the glacier there and the blue front. So we have the crevasses on the glacier, which you can see, and then the blue front, that is the snout of the glacier, and that is about 100 feet, about 30 meters high, and that will break off, forming icebergs coming into the fjord. They might float up this way. We can feel the wind coming from the end of the fjord, but over the past few days, in fact, the weather has been blowing towards the glacier, so all the icebergs have been collecting at that end of the fjord. You can really see the speed of this glacier. I think moving about 3 meters a day at the moment. In the summer, I've been told between sort of 6 and 7 meters a day, and that great crevassing there. And that compares to just around the corner, we've got the Kongsvegen, another glacier, nice smooth, and over on the left here, a smoother glacier, not moving so fast. If you can see these amazing sort of pyramidal peaks further out, those are the Tre Krona, named after the three old kingdoms of Scandinavia, Svenska, Danska, and Norra. And those are even further away. Those are about sort of 25-30 kilometers away, just to give you a sense of the distances out here. And this is where the fjord is, where we are sampling. So the team are about to set off into the small research vessel, the Partition, and head out onto the fjord to collect the water samples to tell us how the waters here are changing. Looking both at ocean chemistry, so the amount of carbon dioxide getting into the water and how that's changing the nutrients. Looking at the nutrients as well and the oxygen levels, and also looking at the plankton and plastics out there. If I just come round, we've mentioned before that we are at a research station, and that's exactly what I'm going to show you now. So we have the UK Arctic Research Station, this great building here. And although we do head out every day to do our research in the great outdoors, the great wilds of the Arctic, we come back here of an evening to rest, recuperate, and organize our equipment. So we've got bedrooms down these first windows here. We each have a individual bedroom. In fact, that window just here is the cold store, so any samples that need freezing are kept in there. And then further down, we have a sitting room, lab space, office space, everything you need to operate up here in the Arctic. And really amazing to have hot showers and good food after a long day. So although it may not seem that it's very cold, I'm not wearing gloves, I've just got a jumper and a jacket on. When you're out on the water, a couple of days ago with the wind chill, it was minus 25. And your hands are in seawater down to sort of minus 1.5 degrees Celsius, and really, really chilly, getting to points where you can't feel your fingers. But it's amazing to come back here, warm up, have a shower, and get refreshed. So we'll just go back in now and set the cameras up, and then Ellie will join me and we'll enjoy going through some of your questions. Just shut the door here. Take the great hat off so I can actually hear properly. Amazing, sort of you can't hear anything with those hats on. And get the mic set up again. Here we are. Fantastic. Really, really great to be able to share a little bit of the Arctic with you. And we are then looking at the questions you're sending through. So the first questions coming through from Tuckerton Elementary School. So the first question is, are there polar bears near you? Great question. Polar bears are something we have to look out for all the time. The polar bears are more likely to be further north and further east. So if you saw those peaks over those onto the north and east coast of Svalbard, where there is more sea ice, and they'll be hunting for seals on the sea ice out there. As the sea ice there decreases into the summer and the hunting isn't so good, they may well head over this way, and we have a lot of birds nesting in this area over the summer, and bird eggs and fledglings make a great snack for polar bears. But at any time of year, it is obviously something that we have to look out for. And if we go on snowmobile, on skis, or on foot outside the immediate settlement, then we will have to carry safety equipment, so rifle flares and that kind of thing. Ellie, hi.
Hi. Hi, everybody.
Wonderful to have you join this session, to escape from behind the camera.
Yeah, just warming my fingers up after being outside.
It is amazing. I mean, it's very hard to describe that if you're holding metal up, even if it's just -5, -10,
Yeah.
Your fingers really start to go pretty quickly.
Absolutely. So I have I have a cashmere wrist warmers, which is quite useful. But then I do wear a thermal liner glove and then a kind of a neoprene or an insulating glove as well. If I'm out and about moving around, then I'll have another glove on top of that and then a mitten on top of that as well. But as soon as you're operating the camera, you need your fingers loose, so you can't wear any big bulky mittens. So I'm down to those 2 base layers. And as soon as you're touching metal, it just you can almost feel it sucking the heat out of you. Yep. It's such a good conductor of heat away from your body that you almost feel it draining your energy as you're touching it. So when you're holding a camera or holding any tools, doing any work, if they're metal tools, normally here they'd be heavily wrapped in rubber or even gaffer tape or something, so that you're not directly touching the metal. And even, you can't see, but I'm sitting on a metal crate, and we've put a layer of cardboard on top of it, which is that insulated cardboard, that crumply stuff that's got a little layer of air. And the difference it makes from sitting on a metal box to just having a thin piece of cardboard on the top, much warmer. So
good. So we hope you don't freeze to the box over this call. Ellie, the next question coming through from Tuckerton is: are you looking for animals? Is this a sort of like a great search for animals?
Good question. Trip? Historically, it would have been. There were some, great explorations of old times where they went off in search of things like the narwhal to prove it was real, because sailors would come back with these stories of mermaids or sea monsters. So there were times when there would be kind of animal expeditions just on the lookout for creatures, great and small. What we're doing now is not specifically looking for animals, so we're studying two different elements. The science team here is looking at ocean acidification and also microplastics, and maybe Jamie can explain a bit more about them. But there are some animals involved in that science, aren't there?
Well, there's some amazing animals. So we're looking really at the plankton in the seas here. And the plankton are those tiny creatures that sort of form the bottom of the food chain in the ocean across the planet, and including up here in the Arctic. And so types of plankton you might be thinking about up here: krill with their big goggly eyes. Compared to their body anyway, they're only about that big. To the copepods, one of Dr. Kerry Lewis's favourite animals.
And one of yours.
And one of mine, yes. Most abundant animal on the planet.
Jamie, how many copepods are there, would you say, roughly?
Roughly, and we calculated this on a previous Arctic expedition. We tried to estimate the number of copepods in the world's oceans, and we came up with 1,347 billion.
1,347 billion.
Yeah, so 18 zeros.
That's a lot of copepods.
It is a lot of copepods.
What's so special about copepods?
Well, if you think about how you get big animals in the Arctic, like the polar bear, so an apex predator, it really relies on a whole chain of eating levels that scientists call trophic levels.
Like the food chain being a pyramid.
Like a pyramid. So you've got so what you're really looking at is, when do you start to get those proteins starting to be involved to allow for these bigger animals? And that's really when you have algae, which are microscopic plant-like. I mean, here the sort of microscopic plant-like organisms, so tiny single-celled algae, and then the copepods will eat those, and then the fish will eat the copepods, and then the seals will eat the fish, and then the polar bear.
So they're a really critical layer in that.
Critical. So if you don't have them, then the bottom of the food chain wipes out, and you don't really have those bigger proteins for allowing for sort of larger life.
So there we go. So they're the transition really from the plant layer, the photosynthesizing layer, into the animal kingdom. Copepods are transferring the energy.
Yeah.
So a bit like a herbivore, a bit like a rabbit eating grass.
A bit like a rabbit eating grass, same layer, except other than being the same position in the food chain, they have no relationship.
Little tiny rabbits.
Little tiny rabbits that swim.
A lot more of them.
And there are a lot more of them. Yeah. So and some of the other sort of like what we call primary consumers, those herbivores, those plant eaters or algae eaters. You have clams up here, or other filter feeding shellfish. Yeah. And your Partition walrus is quite partial to them.
And clams and copepods and walrus actually all feature in our Arctic food web activity, which we did yesterday.
Was it only yesterday?
Yesterday? 2 days ago.
No, it was yesterday.
The sense of time in the Arctic is very skewed because it's 24-hour daylight. But those videos are live on our YouTube channel, so you can watch back and you can do a food web activity and learn more about the copepod and its position in the food web.
I'm just going to end with this question with one last pod that we found, and that's the pteropod.
Oh, yeah.
Also known as a sea angel, and it's got these very, very cool sort of angel-y wings, and I think we've got a video somewhere of that, but also has little devil horns as well, which probably more accurately describes its feeding behaviour, because they are voracious predators. They are tiny wee. but
Vicious little things.
eat each other.
So they should be called sea devils.
So they should probably call these sea
instead of
devils,
sea angels.
but they're called sea angels.
So we've actually got some footage of a sea angel from yesterday, still again, the day before. I'm completely lost track of our days.
The day before, because we were out sampling on the day before.
And so we'll post that shortly on our Twitter. So if you follow us on our Twitter account, you'll see that little sea angel. In the meantime, perhaps the London office can put up a photo or a link to what sea angels look like, or you can Google image them, get your teachers to ask, because they're really cool.
And other search engines will do. Coming through from Tuckerton Elementary, this next up question is what kinds of animal can we find here? And I think we've covered that pretty well. I mean, just to think about some of the larger animals, a minke whale spotted yesterday, walrus, beluga whales, a white whale, and then a range of bird life. So the most common birds finding on the fjord here are fulmars, skuas, eider duck, and guillemot, and probably some little auks. AUK rather than ORC. Coming up.
And the Arctic tern. Did you say tern?
I haven't seen a tern. Have you seen a tern?
We did on the last trip last year. The northern fulmars are beautiful. They glide over the water. Really, really good to see.
And next question from Tuckerton is: are you exploring in the ocean?
Oh, good. Yes, good question. Yes, we are. Short answer. And part of the science that we're interested in is what happens at different depths in the ocean. So it's a very different story on the surface than 10, 20, 30 meters down, and then it's very different again, even deeper. So the deep ocean here is a different world. It's really an exciting frontier for exploration. The deep ocean everywhere in the world is exciting, but particularly here because you get a very specific combination of fresh water from the ice water, the ice melting, and then the salt water, cold salt water from the deep ocean, and how those oceans circulation, those currents circulate around. So it's an unusual place. So yeah, definitely we're looking in and on and throughout the ocean.
Brilliant. We've got coming in from Union Point Academy here. Hi. How long is this expedition and how many teams do we have?
Oh, good question. So we're up here for about 2 weeks at a time. So we've been here for a few days. We've got about 10 days still to go. And that's to provide this coverage to you, to broadcast all of these exciting activities and interviews and so on to you. And our science team is up here for the duration of that as well. So they're out on the boat pretty much every day if the weather is good. They only need to really do, say, 5 or 6 days on the boat or out on the water to get their samples. But of course, in the Arctic, if you need to do a 5-day expedition, you need to plan 10 days to do it in, because you may have bad weather. You have to plan for at least 2 or 3 days of the time. Statistically, probability you're going to lose probably every other day will be a bad weather day, strong wind, somebody might be seasick, all sorts of reasons. Things can go wrong, machines can break, the winch on the boat broke last year. So you always sort of almost double your time needed. And so they're out for that 2 weeks, but this is part of a much longer plan. So this is a multi-year study, because of course anything you gather in 2 weeks or 2 months would only be a single snapshot of this current time. So you need to come back every year, every 5 years, maybe for 5 or 10 years to be able to see a pattern building. And that's what science is all about, really. Yeah,
and it's very true. I mean, I've been on a trip up here. We're doing some glaciology, and we were up here for 2 weeks, and we had one full sampling day because of the weather. So you can just blow through and just stuck on base, or you can go up to what you thought was your sampling site, and it's frozen solid, and there's no way you can access it. So no, you do have to give a good long lead times and spare days for the weather.
We've been very lucky. So far, we've had one. This morning, the team couldn't get out because it was too choppy, too windy. But now it's dropped down a little bit, as you saw just now. It's quite calm and sunny outside, so they have just headed out, or they're just on their way out now. And I was speaking to Kerry, who we'll hear from next week, and she's very happy now because we've got enough samples to, get some data. We've been to enough sites that the trip is worthwhile. We've got enough data. Anything more than this is now kind of a real bonus. So worst case scenario, if a storm comes in tonight and we're trapped in this building for the next 5 or 6 days, it's not a completely lost expedition. Sometimes it is. Sometimes you could come up and not get out at all. You could be sort of snowed in for weeks on end. So all in all, it's been a good expedition so far.
Yeah, very good. And so all the sites, sampling sites we're looking at on the inner fjords, that was towards the glacier, that we were showing you just earlier, that should be completed today. And the sites that we're still looking at are in the outer fjords, so closer to the open sea. And of course, really, you have to wait for very good weather to brave getting out there.
And we're relying on the expertise of the very experienced local boat captain, who is brilliant, and he really knows not just the weather conditions, but he also knows the fjord and the icebergs and the kind of transport and movement of the ice around in the fjord. So he was saying, for example, this morning, heading out to the outer sites this morning would have been an absolute no-go because there's so much shifting ice around. There's a lot of icebergs that are moving quite quickly, so he wasn't comfortable with going out, quite rightly. Whereas this afternoon,
I'm only laughing because the closest I've ever been to an iceberg in a boat was on Wednesday.
He said there's quite a lot of broken ice, a lot of loose ice is coming down off the glacier, and there's a lot of chunks of ice, moving around, and it's quite dangerous navigating those in a relatively small boat.
Indeed. And so Tuckerton interested, and so we didn't answer that second question, was the number of different teams that we have.
Oh yeah, good question.
I think we work with a variety of different teams on the live. So with Arctic Live, we've been working with a variety of teams over the years, but this year, and next year, working with a team from the University of Exeter, Plymouth Marine Laboratory. For Plastics Live, which will be coming up in the autumn, we will probably be also working with Exeter and other researchers. For Coral Live, which is in Curacao in the Caribbean, that is working with the University of Amsterdam.
Yep.
And so some amazing sponge researchers there. Also with, I'm trying to remember where Pim is currently studying. And it's in California somewhere.
Yes, I don't.
California Academy of Sciences, was it?
San Diego.
Or one of these places.
International teams.
International teams, and also the local researchers in at the Kamabi Research Station. So a range of researchers, and it's really important to us that when we do our lives, that it is based in science, and collaborating with science teams is fantastic, because it also gives you a really great insight into the environment where you are, into the natural world, and also how it's changing.
And also on this research base, there are lots of different teams as well. So that's our team that are based here in the UK Arctic Research Station. But in Ny-Ålesund, there are research stations from other countries as well. So we've got the Norwegian team, there's a French team, there's a Japanese team, Korean,
German,
Italian,
Indian, Chinese, Japanese, Dutch.
How many in total? 10. So 10 different nationalities, 10 different countries, all sending their science teams here. And sometimes they will send international teams themselves. So all sorts of different nations and science disciplines, from glaciology to reindeer gut biology, all sorts of things going on up there.
Good lot of microbiology, looking at the bacteria up on the glacier as well. So coming back to the here and now, Tuckerton would like to know the temperature and weather.
Oh, it's quite warm today. What do we reckon? Minus
3 or
4 degrees with
in
wind
Celsius,
chill.
10.
Minus 10.
It's probably pretty nice now.
I think it was minus 15 this morning.
So temperature it is incredibly changeable here. So I have been here when we've had +2 one day and then -22 the next, and that's in Celsius. So you're almost doubling that, sort of 40 degrees Fahrenheit temperature range over a day or so. and that makes life incredibly difficult. I think it's the variability that makes it so challenging. But it's not cold. We're not in the sort of negative 40s
No.
here, although it does feel a lot colder when you're out on the water. So
Yeah.
normally polar travel up on a glacier or on the sea ice, it's quite dry, and so it's that dry cold which you can just kit up for. And then if you are on the water, as the team are now, it's sort of that wet cold that
Wet,
really
cold, gets into your bones.
gets into your bones
Yeah.
and is pretty horrible.
And if your kit isn't waterproof, just the mist and the spray from the water can really make your gear quite soggy, and then you are in trouble, because once you're wet and cold,
You're wet and cold.
you stay wet and cold for a long time. Yeah.
So Richard Lander, Girls' School, asking, have you discovered any new species?
Oh, good question. Again, so going back to sort of historically, where you used to go out and search for big new animals, there aren't any of these large mammals up here that haven't yet been discovered that we know of. Maybe there's some
The ones that we haven't discovered are the ones we haven't
snow
discovered.
beast out
Yes.
there. But something that's interesting about the Arctic region, or the polar regions, is that because it's so inaccessible and difficult to get to and difficult to study, it's almost certain that there'll be all kinds of species of those little small creatures, like the plankton and the even the algae, for example, little tiny creatures in the ocean, that there's very likely to be species that we haven't come across yet. And it's not surprising at all. If you went out and sampled in these regions, you probably would find a new species of something out there. Yeah.
So it's not something that we're focused on, but what were you to be focused on, then you might well find a new species.
And something else that's quite interesting, as well as the ice is melting in recent years, as we've got more melt, is that we're revealing, as you mentioned earlier, the microbiology. There's some interesting bacteria that are being discovered or rediscovered. So these are bacteria from many, many years ago that were trapped in the ice historically, and now being released again from the melting. So that's really interesting, because that sort of shifts the food chains, and it shifts the microbiology of the region.
Another question from Richard Landers, Girls' School, is why are we studying the Arctic?
Oh, good question, and it's an important one. Several reasons. I think possibly the most important, is that the polar regions are they're seen as something called an early warning system for the rest of the world. So the effects that happen around the world are seen more dramatically here than anywhere else. So things like global warming has a bigger effect here than it does at the equator and in other regions. And one of the reasons for that, for example, is that if you get warmer temperatures, you get more sea ice melting here. The ice melting means that you don't have as much ice cover. So if you were to look at an old map of the North Pole, you'd see quite a vast expanse of white. And if you look at a new map, unfortunately, that's shrinking. It's reached a record low in 2012.
Yep.
Big cyclone came through and melted a lot of the ice, and there's not much left. Now that pole, that ice cap, that big white cap, acts as a big giant mirror, a big reflector of heat. And when the ice melts, you get the blue sea underneath, which instead absorbs a lot of the heat. So instead of having a cooling effect, we're switching to having a warming effect. So that's why the increase in air temperatures around the world is almost being sort of sucked into the oceans at the pole, in the north, in the Arctic, and it sort of exaggerates the effect. So the impacts of climate change are seen quite starkly, quite strikingly up here. So it's a good place for scientists to come and study, because it's happening here first and it's happening here fastest. So if we can see what's happening here, that's almost a predictor or a warning for what might follow later on in other countries. So it's a good place to start. Is that accurate? Would you?
I mean, it's just looking at sort of what we're. I mean, the focus of the study this year. So we've got ocean acidification, which is a process by which atmospheric carbon dioxide dissolves into the ocean and changes its acidity level, or pH.
Yeah.
And as you were saying, the many environmental changes are happening faster in the Arctic. And the reason why it's happening faster in the Arctic for ocean acidification is that colder waters are able to hold more gas than warmer waters, and you just know that if you warm up a can of fizzy pop,
fizzy drink,
and then it will spray everywhere because the gases come out. So that's something that's quite easy to observe in where you are. But that means that the oceans here are contain more gas, contain more carbon dioxide, and that is meaning that these waters are acidifying faster than other seas around the world. So it comes back to this early warning system, this sentinel system for that the polar regions offer for the rest of the planet. The second thing, we're looking at the plastics piece, which we're looking at plastics and plankton. Also, it's really useful to look at these more remote communities where we can isolate the inputs of plastic. So if you're interested in how plastics move through the ocean and where they might be coming from and how they behave, having a community or a fjord system, the recycling here, we've got 17 different types of recycling.
There's brilliant.
We've found one piece of litter. So having a research station next to a fjord where we not discount completely, but we can think about, be able to isolate the sources of plastic pollution and understand its behavior a bit better away from human impact. So I mean, the Arctic, it's not this, it's beautiful and it's stunning and everything else. Those two topics that we're studying, it's really well useful to be in the Arctic to understand them better.
And it's such a shame, really, that the best place to study plastics is a really pristine and beautiful place that's untouched by plastics, because then you can see the plastics arriving and you can see the rate at which it's accumulating. But that knowledge, that information that we can get from here can be used to relay back to the rest of the world and where this plastic is being transported around the oceans, where it's coming from, where it's going. And it does seem, because of the northwards transport of the ocean currents, that a lot of plastic is ending up here. So it's sort of getting trapped here. And so if we know where it's coming from and how quickly it's coming, then perhaps this could be a location. We could identify a location further south that we can almost trap it or stop it, intercept. So there's a lot of valuable insight and valuable knowledge that comes out of being in a very remote, pristine, and a very unique part of the world.
Brilliant. What impact of plastics have you observed on this exhibition? And that's from May, Church of England Primary School. The impact of plastics, it's not something we're directly looking at. So what we're doing is we're currently trawling for plastics and collecting water samples at different depths. We're looking at what might, there's a term called partitioning of plastics and microplastics in the environment, and that's really looking at where are they. So they could be on the surface, they could be in the water column, so in the sort of between the surface and depths. They could be in the seabed and the sediment down there. Not something that we're looking at. We are looking at sort of different depths. And they could be in living things, but what we're focusing most on is where they are in the water column. And the important thing for this is it comes down to working out what harm might be caused, because knowing where it is and how it's behaving allows us to see how it's going to interact with living things and other natural processes. And the second thing is, if we are looking to try and manage waste in any way, if we focus on the surface, we're ignoring. If we find plastics at depth, then we're ignoring the fact that there is a lot of plastic that we wouldn't be able to skim off the surface.
And just to highlight how much plastic we're looking at that's not on the surface, of all the plastic that we know enters the oceans every year, which is about 8 to 10 million tons a year, we can see the plastic that's floating on the surface, because you can look at Google Earth satellite imagery, or you can sort of zoom in and see it floating on the surface there. The plastic that's on the surface, of all that 10 million tons that enters, only about 1% of that is visible floating on the ocean surface. The other 99% of all the plastic in the ocean is not on the surface. We can't see it. We don't know where it is. That's the stuff that's in the water column, it's on the seabed, it's in the digestive system of the animals, or it's washed up on coastlines all around the world. So really being able to map where that plastic is and where the big plastic and the small plastic and different types of plastic, that whether it floats, whether it sinks, whether it hovers at certain depths, is really, really important, because if you have a certain type of plastic that has particular density, for example, and it hovers in the water column at a certain depth, then you almost have like a layer of plastic in the ocean that will affect some animals more than others. If there's an animal that lives below it or above it, it's not going to be affected. But animals that maybe have migration patterns, like turtles, at that same depth, they're going to be swimming through this plastic soup. So it's really important for us to work out where in the ocean and where around the coastlines the plastic is ending up and how it's moving, because then we can look at those wider impacts. So although, as Jamie said, we're not looking directly at the impacts here, some of those impacts on animal life, for example, you've got entanglement and physical damage where things get caught up in the nettings, fishing nets and things. Ingestion, so the eating of those plastics. There's a lot of study going on at the moment. Because plastics are quite new, we don't really know what the impacts might be. There's a lot of early indication that toxicity or the chemicals from the plastics could cause damage to anything that eats them, and how that works its way up through the food chain, as we spoke about earlier. But then also, moving away from animals, there's all kinds of impacts of plastic, even if you don't care about animals, which we all do, of course. But even the most cynical person who lives in a city and doesn't care about wildlife, plastics are causing all kinds of financial damage, because they're tangling up shipping big ships, propellers and things, and it's costing trillions of dollars to the fishing industry and the shipping industry. It's affecting fishing. So even the most hard-hearted businessman who doesn't care about wildlife, it's still costing him a lot of money as well. So he should also care about plastics.
There we go. Lots of reasons.
Keep watching the Encounter website and our newsletter, because we're going to be bringing you Plastics Live, hopefully.
Plastics Live and a whole range of resources for elementary, middle schools to understand the issue of plastics a bit more. The questions coming through now are a number of schools thinking about sort of what do we do to help the ocean. We're describing a lot about what we're studying to understand the changes that are happening in the ocean while we're doing it here up in the Arctic, and some of the joys and travails of working in this kind of environment. But what can classes watching start to do to help deal with some of these issues that we're talking about and help deal sort of support the oceans?
It's a really, really great question, and the fantastic thing is that you're asking it. It's so important that we don't just absorb this scientific information, get presented with this is what we found out, we've gone and researched it, and these are the results. The next stage is translating that into action, and how can the average person use this knowledge or use the science to help play their part and contribute to creating a better world for all of us. So there are some things that everybody can do. It might seem that you're very disconnected from the oceans if you live in the middle of Texas or somewhere. You might think, well, what can I do? But as we talked about earlier, carbon dioxide is one of the biggest contributors, greenhouse gases, to climate change, global warming, and that ocean acidification. So very simply, reducing your carbon footprint is a good place to start. A couple of key ways to do that would be to reduce the number of flights that you take, because they use an awful lot of carbon dioxide, produce a lot of carbon dioxide. So carbon offsetting, planting trees to absorb as much carbon as possible, and trying to reduce the amount of meat that you consume, particularly beef, and switching, for example, to things like a plant-based diet or a vegetarian diet. And even if you just started with something called a meat-free Monday, which is a bit of a trend, but one day a week, doesn't have to be Monday, switching to a plant-based diet and maybe reducing more and more. Those are all very simple things that we can, big changes that we can make, but have a really, really big impact.
And I think if we look at both the plastics piece and the sort of ocean warming particularly affecting corals in the news with the bleaching events and then ocean acidification. Those are things that you have an impact on wherever you live.
Yeah.
That doesn't matter whether you're next to the ocean. I think first of all is understanding. We've got these questions coming through about sort of ocean literacy and what should it be taught more in schools.
Yes.
Understand the issue, understand what the causes are, and then that gives you the skills to sort of navigate what's being said in the media, what people will tell you, oh no, you're wrong, or it's actually like this. The more you learn and you learn from the science coming out and you have the evidence to back up your arguments, that puts you in a very strong and robust position. And then it's really translating that into action. And for me, that's really about sort of the heart aspect of looking at some of these, caring about the natural world, whether it's financially driven, as Ellie was pointing out, or the fact that the ocean is just A, staggeringly beautiful, the marine world, but B, I'm going to sort of almost trump the finance piece and go for breathing.
Yes.
So
absolutely.
If everyone in the class is watching can take a big breath in and out. One more. Now the oxygen for one of those breaths was produced by the ocean. So if you like breathing and living,
every second breath that you take is from the ocean.
Then if you like breathing, if you like living,
that is a reason to care.
That's a reason to care. Ocean health is immensely important. Provides food and primary source of protein for over a billion people. Trillion people, I don't know. Trillion copepods.
All those copepods.
Over a billion people. Moderates our climate. Does so much for us. Worth millions and millions to coastal communities, from tourism to sort of housing and everything else. So it's definitely something we need to look after. And I think, as you were saying, let's just focus on examining how we travel, how we eat and how we live in terms of reducing our carbon emissions, and then some very simple actions that we can have in terms of reducing our single-use plastic and refusing single-use plastic, and having reusable water bottles, having not using plastic bags, those types of things.
Wooden toothbrushes, there's all sorts of plastic-free alternatives now. The great thing is, 5-10 years ago, I went plastic-free 9 years ago, and it was very, very hard to find alternatives. Nowadays, there's loads of plastic-free options, so you can find a whole load of different things. Can I give the students three challenges? Three. This is your homework. Number 1, I want you to calculate your carbon footprint. So the office in London is going to put a link up to a website where you can calculate your personal carbon footprint based on what type of transport you use to get to school and how much electricity you use, that sort of thing. And do it for 1 week, and then try and make some changes and see if you can reduce it. Second challenge is to do a plastics audit or a plastics inventory. Now this one parents don't like, because I say to students, try and keep every piece of plastic you use in your household. Don't put it in the trash. Just keep it maybe in a separate bag, just in your living room or in the kitchen. Just keep it there. Let it pile up on the kitchen table.
Bathtub.
Yeah, put it in your bathtub. Great. That's a really good idea. Just for a week or two, and just to see how much plastic you produce as a family and how quickly it builds up. Because when you take the trash out every day or every other day, you sort of forget about it, and maybe you don't realise how much you're producing. So try that for a week as well, and then maybe the next week see if you can get it down. Get it, a challenge with your brothers or sisters or your neighbour or friends and family to see who can reduce their plastic the most. And my third and final challenge is, it's not just you that can act. You can also demand action from your governments or your local authority. So how about...
Or your school.
So how about finding out who's in charge of sustainability or who's in charge of recycling? Who are the key people in your school, in your local district, your local government? Maybe get your teacher to help you find the names and addresses, and you could write some letters to them demanding positive change or some new legislation. So the UK just a couple of days ago has announced that it's considering climate change as an emergency. So that means that there will then be a lot of pressure to act. It's happening around the world. You've seen the school strikes potentially, lots of young people getting involved. So you can also be a voice as well as a driver yourself.
Brilliant. Very sadly, Ellie, we're out of time. Yeah.
Oh. You're asking such good questions.
Exactly. Very, very good questions, both in terms of understanding the science, the Arctic, and also what we can all do about it.
Absolutely. Thank you so much for your questions. I'm going to head around the camera so that we can say goodbye.
There we go. Thank you very, very much. Do join us in about an hour's time for a live investigation looking at keeping warm. And then we are delighted to have Nick Cox, Station Manager here at the UK Arctic Research Station, back in about 3 hours' time. Then we will be off exploring, researching and sampling over the weekend and joining you back with broadcasts from Axel Arctic Live on Monday, Tuesday, Wednesday next week, looking more at ocean acidification, marine plastics, microplastics, and also the adventures of science commuter Ellie Mackay. So that will be on Wednesday next week. So very much hope you will join us then. Until the next time, it's goodbye from the Arctic. Bye bye.